So I'm just going to go walk through this with you kind of quickly just to catch up a little, and we'll do some work on, so we have time to do some other work. So it says evaluate the 6 trig functions for theta. So here we have 5 pi over 4. 5 pi over 4 is 1 1/4 pi, which puts it in quadrant 3. So this is our, right there is our values for x and y. So what we want to say is, okay, that means the cosine of theta is equal to negative the square root of 2 over 2. Okay? The sine of theta is equal to negative the square root of 2 over 2. Right? Because they're the same. This is the x value, and this is the y value. Okay? All right. The tangent of theta is going to equal, remember, it's the sine over the cosine of the y over the x. But since the y over the x are the same, this is just 1. So the tangent of this is 1. This minus the square root of 2 over 2 over minus the square root of 2 over 2. Right? Then, all we're going to do here is we're going to say, well, then the secant of theta is equal to just the reciprocal of this. Yes, it would be the same. Exactly, because it's just the reciprocal, right? So the cotangent of theta is going to be x over y, but it's still 1. Doesn't make a difference, right? Here it's going to be 2 over the square root of 2, and if you rationalize it, it becomes minus 2. And the cosecant would be the same. I'm sorry, minus the square root of 2. Minus the square root of 2. Does this make sense to everybody?
You lost me with cosecant.
The cosecant, okay, so the cosecant is equal to 1 over the sine, right?
Right.
Okay, so that's 1 over minus the square root of 2 over 2, which really just is the reciprocal, so this is minus 2 over the square root of 2. And if you rationalize this, you just get, actually it's not, it's minus the square root of 2, right? Because we'll multiply by the square root of 2 over 2, over the square root of 2.
Oh, okay, I see that now.
You see it now? Okay, very good. Thanks for asking, by the way. Please ask these questions. Any other questions? All right. Okay, so now let's do it in the order that I'd like to see you do it in. So the first thing is, if you have theta, first thing I want to do is, well, yeah, this is how I want you to answer. I want to know what the quadrant is, what the reference angle is, and what the value is. And when I say the value is, I want the ordered pair. Okay? And then once we have that, we can just do the x and the y very simply. Now, how many people have a unit circle out that they're looking at? Put it away. It won't help. Like right now, I just want you to know that when you come in for tests, you will not be able to use a unit circle you will have to put it away, and without a calculator, you will be lost. So I'm trying to train your brain right now to learn this. Yeah. Well, all we have is we have these 3 points. Remember, we have the square root of 2 over 2, comma, the square root of 2 over 2. You can draw it, but what I'm saying is it's not that big a deal to get this in your head and not have to draw it every time. Just try it while you're on lecture, okay? Just try it. And then the reverse, right? The reverse. So really, we're not memorizing a lot. Yeah, just while you're on lecture, just try it. Like, work with me, because if you do, you will be very happy when you know this unit circle, okay? So put your unit circles away, and let's see what we can do. Okay, 11 pi over 6. What quadrant is it in? Quadrant 4. Very good. Exactly. Does everybody know how we get quadrant 4? Well, 11 pi over 6, turn it into a mixed number, and we get 1 5/6 pi. If we look at a circle, here's 1 pi, here's 2 pi, here's, I'll just write it as 1½ pi just for the moment. We don't call it that, we call it 3 pi over 2, but I'll just write it as 1½ pi. Is 1 5/6 pi bigger or smaller than 1½? Is 1 5/6 bigger? It's bigger, right? Is it bigger or smaller than 2?
Smaller.
Right. So that places it between this point and this point, doesn't it? Which is quadrant 4. Does that make sense? So important, first step, what quadrant? Second step, what's the reference angle? So the reference angle is this angle right here. What's the reference angle? Anka, stop answering. I got it. You're doing great. I'm thrilled. So if you got this, like you're good to go, stop answering for the moment, because I want to see who's struggling, who's getting it. Okay? So there's a few of you I know really have it. No, it's great. I love it. I love it. I'm very happy about it. But I just need I need to kind of sort through the people who know it and the people who don't know it. That's all. I'm thrilled, by the way. Okay, so the reference angle is pi over 6. Who doesn't understand why it's pi over 6? Okay, Donnie. What part do you not understand? I need a question or a... Like what is it that I'm what is it I need to say to show you where it comes from? The angle that the terminal point makes with the closest x-axis. So if this right here is 11 pi over 6, right? Then okay, no problem. Then this leftover part has got to be pi over 6, doesn't it? Because that would make, so 11 pi over 6 plus the reference angle makes 2 pi. Doesn't it? Okay, good. Richard, how about you?
Yep, it makes sense as well.
Okay, good. So the reference angle always is from where, like if it's in quadrant 2, this is the reference angle. Because That's the angle. It's the angle. What we're doing is looking at triangles that are equivalent, basically. So in each quadrant, the triangle that's equivalent to the triangle in quadrant 1. Here, let me see if I can do this better. So, hold on one second. Oops. That's not what I wanted to move. I might have to move it first. Okay, let's try again. So, the reference angle, if I have a triangle in this quadrant, and I call this the reference angle, I'm not even going to tell you what the angle is, then in each quadrant, the same triangle has, these angles are exactly the same. If the angles are the same, doesn't that make the triangle have the same base and height? So if they have the same base and height, then these points are the same. They're just positive and negative depending on which quadrant you're in. Okay? That's why the reference angle is important, because with the reference angle, we don't need the whole unit circle. We really just need the first quadrant. And not only that, you will need reference angles down the line when we get into more important, bigger things. So just really, the reference angle is a very big deal. Very big deal. Learn what the beginning of this course is a very big deal. It's what we are going to build the rest of the semester on. Without this, the rest of the semester will not go well. Get this down solid. Okay. So that's where the reference angle comes from, which is why it's pi over 6. Now the value associated with pi over 6 is what? What's the ordered pair? If you know it, like you've answered a bunch of times already today, then don't answer. If you're not sure, let me know. Okay, so notice that now that the people who have been answering a million times are not answering, there's a bunch of, so here's what I'm going to do. I'm going to start just going down I'm going to call people's names, okay? And if I say your name wrong, who's writing on the board? Whoever's writing on the board, stop writing on the board. I'm not kidding. If I have to, I'll take all your permissions away. I can take all your permissions away so you can't do anything. Stop writing on the board. Okay. So, what we want to see, so pi over 6 is the longer, has the longer x and the shorter y. So that means it's got to be in this order. Square root of 3 over 2, comma, 1/2. And it's in quadrant 4, which makes, is the x value the same? Is the x value positive or the y value positive? Kirkland says they're both, Kirkland says they're both. So x value is positive and y value is negative. So that's the answer. Right here. This is the most important part. Because from here, there's not really that much work to do. Once you get that, well, that means that the cosine of theta, which is my x value, is the square root of 3 over 2. My sine, which is my y value, is 1 over 2. My tangent of theta is equal to 1/2 over the square root of 3 over 2. right? That y over x, and this becomes, yeah, you're right, sine is negative, thank you. So this is going to be negative here. So this becomes negative 1 over the square root of 3, which is going to equal the square root of 3 over 3, negative. Right? Yeah, if you memorize pi over 3 is the bigger angle and pi over 6 is the smaller angle, you're going to be asked for, so whenever you're not given a calculator and you're asked for trigonometric values, you'll only be given ratios of these values, okay? But for reference angles, I can give you anything, because you should be able to find the reference angle no matter if it's one of these or not. You'll see. But does this make sense? Well, we're going to do the next 3 pi over 2. So here, let me get a new page. So 3 pi over 2. Where's 3 pi over 2 on my unit circle?
Quadrant 3?
It's actually not in a quadrant. It's actually right here. It's actually on the y-axis, right? It's not, when they're on the axis, we don't actually have a quadrant for them. Yeah, exactly. Exactly. Catherine, you said call you Katie, right? Okay. Just trying to remember from last week. I know some people gave me their nicknames. So because of that, what's my ordered pair here? If this is a unit circle, that means the radius is 1. That means each one of these is 1. By the way, that's what unit circle means, is that the radius is 1. Okay, unit, 1. So if that's true, what's the point down? Yeah, it's 0, because it's 0 in the x direction and minus 1 in the y direction. Okay, is everybody with me? All right, so that means our cosine of theta is equal to what? 0. Sine theta is equal to
-1.
-1. Tangent of theta, which is equal to y over x. Nope.
Undefined.
Undefined. Can't divide by 0. And then the secant is equal to 1 over cosine, which is 1 over 0, undefined. The cosecant is equal to 1 over sine, which is equal to -1. And the cotangent is equal to, instead of 0 over -1 over 0, it's 0 over -1, which is 0, so it is defined. Okay? Good? Questions? Okay, so let's just go quickly over this. The domain of the cosine is all real numbers. That means element. So that says that T is an element of real numbers. Again, for sine, it's defined everywhere. Tangent, what this means is, basically, it's not defined where cosine is equal to 0, which is at pi over 2 and 3 pi over 2. That's what that meant. So don't get too caught up on this. We'll learn this notation later. And then, of course, the reciprocals all have a restriction on 0 being in the denominator. Okay? Does that make sense? Oh, that means real numbers. So this means T is an element of real, or in the real number system, whatever you, element of real numbers. So it's a real number. Okay? Okay, so now it says finding function values given a point on the unit circle. So I'm given this point on the unit circle, right? And it says find all the 6 values of the trig functions. So what's the cosine of theta? It's the x value, minus 7 over 25, exactly. And so on and so forth. Does anybody have a question about this? If not, I'm not going to write them all down. Does anybody not understand what we're doing here? Speak now.
Is there an easier way to remember that cosine is x and sine is y?
Is there an easy way? Okay, how about C comes before S, and it's an ordered pair?
Okay.
I mean, that's the best I got. Okay, Stacy, elaborate where? On this? Well, remember that we said that cosine is always the x value. Sine is always the y value. So I'm just picking it off of that's an ordered pair up there. Does that make sense? Yeah, this is, don't overthink it. I'm giving you everything you really need. There's no hidden little things in here. It's pretty simple, I think. I think there's a question. There's a question. I'll just do something like, there's a question in Alex. It says, if you have an ordered pair that's like x, comma, 5, 8. I'm just making up a number, right? It says, what is x? If it's on the unit circle. How would you find x? Who can tell me how to find x? So let's do this. Remember, anything on the circle can be created as a triangle. Exactly, Louis, exactly. So we have x, we have 5/8, and we know the radius is always 1, which is the same as the hypotenuse, right? Does everybody understand what I'm saying? Like if I put this on a circle,
So that works as long as you know the radius.
the radius is always 1 on a unit circle. That's the nice thing about a unit circle. That's what the unit circle means. Do you know what I'm saying?
Yes.
So, I mean, I know this is no longer a circle, but I just kind of try to write it over the top of it. So, a unit circle always means the radius is 1. That's why we call the unit circle. Whenever you have the cosine and the sine, you always have to have a ratio, and we'll get to this in a minute actually, where, you know what, let's wait on that, what I was just about to say, until we get to it. But if I have a problem like this, I would say x squared plus 5/8, sorry, hold on, that's supposed to be an 8. 5/8 squared equals 1. And then you would just solve for x. That's all. Okay, don't overcomplicate that either. We're really in trigonometry talking about triangles and circles, mostly triangles. How'd you get that, Siobhan? Probably not, but how'd you get it? Let me do it. No, you can't do that. Okay. Yeah, let me do it for you. So you have to say x squared. You can't just take the square root of both sides and take off the squares. So like, look, 3 squared, would you say that 3 squared plus 4 squared, so let's see what that equals. This is actually equals 5 squared. Let's see why. So we have 9 plus 16 is equal to 25, okay? So does everybody agree that this is true? Okay, good. But you wouldn't say that 3 plus 4 is equal to 5, would you? So you can't just take the square root and take the squares off. Really bad mistake. Okay? So here's how you have to do it. And because I know that you can't get that value that you just, whoever told me that value, put away your calculator. Who is it? Let me see. Who is that? Darla, put away your calculator. Thanks, Anka. So we have x squared. Really, guys, put away the calculators. If you don't put away the calculators, you will not learn what you need to learn, I promise. Your brain has gone stale. This is how you have to do that. Okay? Like literally, if you can't, you should pretend like you're in my class. And I'm telling you, everybody who's been in my class before knows, if I see a calculator out, I will tell you to put it away. If I tell you to put away more than once or twice, I will take it from you. Put your calculators away. You need to learn this on your own. Okay? I will tell you when you can take out a calculator, but not for this. There are some, there's some ALEKS problems that I know that you can use a calculator for. When we get to that part, I'll tell you this is a calculator question. And then, because we're not using ALEKS, we'll take out our calculators. But for right now, no. All right. That's what I'm saying, you guys. You guys don't know how to use, you guys have used calculators too much. You don't know how to do arithmetic. Sorry, that's not a 4, that's a 9. Okay? All right, so let's answer these questions. It says, see, thanks, Uncle, I appreciate it. Your brain already has this information in it. You just have to stop for just a minute. And I know you're like attached to those calculators. I know you are. Your phones and your calculators are your life. I'm clear about it. And I'm like basically telling you I'm going to kill part of you by taking away your calculator. But I'm going to replace it with something better. Your brain is going to start working. Okay? Just trust me. Okay. All right, so we have cosine of t is equal to minus the square root of 2 over 2, and we know it's in quadrant 2. Okay, so now what we're going to say is, first thing we're going to do, what's the reference angle that goes with this in quadrant 1? Let's do it in radians, not in degrees, radians. What's the reference angle that gives me positive square root? We're just going to make it positive. Good. Pi over 4. Exactly. Okay? Now, we know that's the reference angle, and we're going to say, okay, well, that's in quadrant 2, because that's what they're telling us. So in quadrant 2, this is the reference angle. Which means what I really want to know is, what is this value? How do I find that? A. We're working on A right now. I want to know how we get that angle. Exactly, pi minus pi over 4, which is equal to, remember, this is 4 pi over 4 minus pi over 4 is 3 pi over 4, and that's the answer. Okay? How many people in the class are never on campus? You're just strictly an online student. Nobody? Well, that's good. So listen, if you're having problems with any of this stuff, just come see me. We'll work it out, okay? Come to my office hours. My real office hours, I believe, are online now. Okay, so now let's do B. B is harder, I would skip it. So when we do B, we have to say the tangent of t is equal to the square root of 3. So let's do this last. That's last. Okay? Well, I know the tangent is going to be equal to the sine over the cosine, right? The y over the x. Okay? So the best way to look at this is, I only have a couple of points. I have the square root of 2 over 2, square root of 2 over 2 combo. And I have the square root of 3 over 2 and the 1/2 combo mixed either way. That's it, right? Otherwise, I've got to take out my calculator, and this is not a calculator question. So does everybody understand that I don't have too many choices here? Is that clear? Okay, good. So what I'm going to do is I'm going to say this is the same as the square root of 3 over 2 over 1/2. Because I can just say, here, let me do it slower. Because this is this is a little harder, I know. So if I have the square root of 3, let's make it the square root of 3 over 1, right? Well, I'm going to multiply both the numerator and the denominator by 1/2. And I get this. So now I know what's the reference angle that gives me that y value being square root of 3 over 2 and the x value being 1/2. Pi over 3, right? We're not going to answer in degrees right now. We're just going to do radians. Yeah, Damien. Was that Damien? Do you have a question? Okay, no problem. So we know this is our reference angle, and it's in quadrant 3. So we're going to say, okay, our reference angle, it's in quadrant 3. So here's my reference angle. So what is my actual angle? Not 2 pi minus pi over 3. Yeah. Not 2 pi over 3. What quadrant is 2 pi over 3 in?
Quadrant 2.
2, exactly. So it can't be there. It's in quadrant 3, so it can't be 2 pi minus pi over 3. That would put me in quadrant 4, exactly, Luis. So it's really the same as pi plus pi over 3. Because I can go, here, let me see. So I can say, okay, here's pi plus pi over 3, right? So that's 4 pi over 3. Are we good? Any questions? Okay. I'm not going to go through all these. Well, the tangent is the y over the x, right, Siobhan? Okay. So it tells me it's the square root of 3, but I only have a couple of choices. The only thing with the square root of 3 is either the square root of 3 over 2, comma 1/2, or 1/2, comma square root of 3 over 2, right? 2. Right? Those are my only choices. They had the square root of 3 in them. Okay? So notice they both are over 1/2. So I just say, well, if I take this and I just put them both over 1/2, then I can say, well, this is my y and this is my x.
Right.
And when the y is equal to, so I'm looking for this point. And where does that point occur? Well, that point occurs where the y value is greater than the x value, so that's pi over 3.
Okay.
Does that help?
Yeah.
Okay. It's just that, honestly, all this is practice.
Oh.
Once you understand what I'm telling you, then if you practice, you'll get it.
Yeah, I get it, because I forgot that it was supposed to be in quadrant 3 as well.
Oh, okay, gotcha. Yeah, we had both of them. Yes. First you find the reference angle, then you put in the right quadrant.
Alrighty.
I'm not gonna, we already know all this stuff. We already talked about this a lot. I'm going to find stuff that we haven't, because we don't have a ton of time. We already did this. Okay, so now we're going to expand a little from, now notice how here we have, we used to have, up until right this second, we had that the sine of theta is equal to y, right? But now look, it says y over r. Well, if I'm on the unit circle, then r is just 1, isn't it?
Right.
So go ahead.
So in any other circles that are bigger or smaller, it's not 1, it's whatever the radius is.
It's over the radius. It's always a ratio. That's all this says is once I take the circle and I'm not on the unit circle, I can change the size of the circle. So now if I have a triangle and I call this x and I call this y and I call this r, if r doesn't equal 1, then I could have a triangle where this is equal to 3, this is equal to 4, and this is equal to 5, right? 3, 4, 5 triangle. Now I can always make it be the same as on a unit circle by dividing everything by 5. Now my cosine, if I divide everything by 5, my cosine's 3/5, my sine's 4/5, and again my radius is 1. But what I'm doing is just making similar triangles, aren't I? Y'all see that? Is there any question about this? So this is where, like, a lot of you from high school learn SOHCAHTOA. I know, that's how they teach you in high school, right? Okay. So the sine, if here's my angle, the sine is the opposite. The opposite means the opposite of the angle, which is y, over the hypotenuse is r. The cosine is, adjacent means next to, so it's this side over the hypotenuse. And then, exactly, that's all. Okay? So that's where SOHCAHTOA is. If you like that, go use it. If you, whatever works for you, I don't care. Just remember this stuff.